In this video, we will look at the application side of linear relations. So let's start with our first example. The celebrations banquet hall uses the equation C equals 50N plus 1,000 to determine the cost for a hall rental, where C represents the cost in dollars and N represents the number of people attending. So in this scenario, I did give you the equation just as a little warm-up before we get our own equations from scenarios. So let's start off by completing the table of values. Now we have the freedom here to pick how many people we want to look at. Now when you're talking about a banquet, you're not going to invite 1, 2, 3 people, so I'm not going to go up by ones. But what is very important is that in your table of values, you should always start with 0. So we'll start with the cost for 0 people, and then I'm just going to go up by 10 because that's what I also have on my graph. And now I'm just going to use my equation. So wherever I see n, I'm going to replace it with the number of people I have chosen. So 50 times 0 plus 1,000. 50 times 0 is 0, plus 1,000 is 1,000. So I'll go ahead and plot that point. So at 0 people, the cost is 1,000. Next, for 10 people, 50 times 10 plus 1,000. 50 times 10 is 500, and when I add it to 1,000, we have 1,500. So I'll go ahead and plot that point. 10 people, 1,500. Next one, 50 times 20 people, that's 1,000, and when I add on the original 1,000, now we're at $2,000 for 20 people. And we can just continue. Now you might see a pattern at this point. Because I'm going up by the same number of people, my total cost is increasing by 500 each time. So you can use that pattern to continue your table of values or continue using the equation. 50 times 30 is 1,500. So when I add the 1,000, we're at 2,500. And finally, 50 times 40 is 2,000. And when I add 1,000, we're at 3,000. Because we are dealing with linear relations, and I did notice that the equation is in y equals mx plus b form, just with different variables, this should give us a line. So when I connect my dots, it is a line, so I know I'm on the right track. Now normally we would put arrows at the ends of each side of the line, but in this scenario, it wouldn't make sense to put an arrow right here, because if I were to continue downwards, I'd be in the negative people and negative costs, which just doesn't make sense. So I'm just going to put my arrow to the right. Okay, what is the y-intercept of this relation and what does it represent? So here's my y-intercept right here on the y-axis, and it is $8,000. Now this represents the cost for 0 people, meaning it's probably the rental fee or rental deposit. Next, what is the slope and what does it represent? So we can use our knowledge of rise over run here. I'm just going to pick random points that I have nicely plotted. And now we do have to be very careful with our scale here. I'm not just going to count the boxes because that doesn't make sense. So for my rise, I'm going from 1,500 all the way to 2,000. That's my rise. That's a $500 increase. For my run, I'm going from 10 people to 20 people. So that's 10 people in total. So when I do my slope, rise of $500 over run of 10 people, that's 50. Actually, I could have also just found that from my equation at the very top, but I kind of just forgot about it. So here's our slope, here's our y-intercept. Now, my slope is 50. What does it represent? It represents the cost per person. So for every additional person you invite, it's an extra $50. All right, let's do some follow-up questions. How much would it cost for 135 people? So I'm just going to write our equation as a reminder. this was our equation, and when we read the question carefully, we know that C is the total cost, which is what we're looking for, and N is the number of people. So I'm going to replace 135 with N. And here we are literally just simplifying. So I'll do 50 times 135 on my calculator, and I get 6,750. And then I have to add on that 1,000 deposit, which is 7,750. Because this was a word problem, we do have to write our therefore statement. So therefore, it would cost 7,750 for 135 people. Okay, next. How would the graph and equation change if the cost per person increased to $100 per person? So we know that the cost per person is the slope. Our original slope was 50, now they want us to increase it to 100. So the equation would change to C equals 100 N plus 1,000. Now, because the slope changed, the graph would be steeper. Okay, so there's the equation change. The graph changes, bigger slope means steeper line. Okay, and I do expect that connection to steepness, not just saying that the slope is bigger. What does that visually mean? Okay, how would the graph and equation change if the rental cost for the room decreased to 800? The cost of the room was 1,000 and now they want us to decrease it. I am going back to my original equation. So C equals 50N. And then instead of plus 1,000, we're going to have plus 800. Now 800 was the y-intercept, which means if the y-intercept has dropped, the line would start lower. And we can make a note, lower y-intercept as well. Okay. So that's it. We created a table of values, we created a graph, did some follow-up questions, and understood what the slope and the y-intercept meant with reference to this specific scenario. Okay, let's try another one. Billy is hiking down a mountain. He is currently 350 meters high and is descending at a rate of 5 meters per minute. So here we don't have the equation, which is a more typical scenario. And we're going to start off by creating a table of values because that's going to be helpful for our visual and to create the equation later on. So we know that Billy starts at a height of 350 meters. So that is time 0. We're told that he's descending or going down 5 meters every minute. Now you'll notice in our table of values, I decided to go up by 5 minutes. So I need to figure out how many meters he's dropping by in 5 minutes, which means I'll take these 5 meters in 1 minute and multiply them by 5. So that's a drop of 25 meters. So here I'm just going to decrease by 25 every 5 minutes. So we start at 350, we'll end at 325 after 5 minutes, and then at 300 after 10, 275 after 15, and 250 after 20. Now, let's go ahead and graph this relation. So at 0 minutes, we're at 350, so roughly here. Then at 5 minutes, we're at 325. We do have to estimate a little bit. At 10 minutes, we're at 300. 15, we're at 275, so close to 280. And finally, at 20, we're at 250. And now we can connect the dots. And again, here I'm going to draw my arrow at the end of the line on the right, not to the left because I don't have negative time. Okay, what is the slope and what does this number represent? First of all, my line is going down, so I know it's going to be a negative slope. And if I just take 2 points, or I could have looked at my table of values, I know In 5 minutes, which is my run, we dropped by 25 meters. And I really just took that from the table because my graph isn't the most accurate and that I did have to estimate some points. So my slope is negative 25 over 5, which is negative 5, which is actually what we saw at the very top, descending at a rate of 5 meters per minute. So this is the descending rate. Okay, what's the y-intercept? Well, the y-intercept is that starting height. So initial height. So in the previous example, the y-intercept was the starting cost or initial cost. Here it's the initial height. So the y-intercept will always be the start to something or the initial value. And the slope is going to be that rate. Here it's the rate per minute that you're going down. In the previous example, it's the rate per person, the cost per person. Now that we have our slope and our y-intercept, we can write an equation to represent Billy's height. Now, before we do that, we do have to write some let statements because we are going to introduce two variables, one for the height and one for the time. And I know these are my variables for a few reasons. I see them in my table of values, I see them in my graph, and that's what my rate is about, the height change per minute. So let H represent height, let M represent number of minutes, and we know it's a line, so it has to follow y equals mx plus b. In this case, for our y-axis, we have the height, so we know it's going to start h equals, and now we find the slope. The slope was negative 5, and the slope is always attached to the variable, so negative 5m, negative 5 times the number of minutes, and then your initial value at the end. You could have also written this as 350 subtract 5m. That way maybe you see that you're starting at 350 and you're subtracting 5 for every minute that Billy has traveled. All right, let's use our equation for a few questions. How many minutes will it take Billy to reach the base of the mountain? So the base of the mountain means we want a height of 0. So let's just take this equation and replace h with 0. And when we do that, we actually end up with a linear equation that we have to solve. So I'm going to bring negative 5m to the left. That way it turns positive, and then we also have our variable in a more familiar place. And then I need to isolate for m, so I'm just going to divide both sides by 5. So this is just a two-step equation. And I get 70. So that means in 70 minutes, Billy will be at the base of the mountain. So therefore, it will take 70 minutes for Billy to reach the base. All right, let's look at some examples where we're changing our equation and graph. So how will the equation and graph change if Billy starts at a height of 350? He originally started at 350, so we are changing the y-intercept here. The new equation will be h equals negative 5m, but instead of 350, we'll have 450, which means the line will start higher. Because the y-intercept is larger. How will the equation and graph change if Billy descends at a rate of 7 meters per minute? So that means we're changing the slope because the slope was the 5 meters per minute, but now we want it to be higher. So height will equal negative 7m plus 350. Now, the line is still negative, so I don't have to look at the sign for that, but 7 is greater than 5. Which means our line will be steeper. So these questions are two steps. 1, write down how the equation will change, and 2, explain what that change means. If it's about the y-intercept, is the line starting higher or lower? If the change occurs with the slope, is the line steeper or more shallow? Make sure you give that detail with reference to this scenario. All right, let's summarize these findings. So we know in a regular knowledge question in y equals mx plus b, m is the slope and b is the y-intercept. But now in terms of the word problem, we have to look for some key words. M is the rate of change, which is slope. And we want to look for that per information. Price per person. Distance per minute. And B represents the initial value. So the starting height, the starting cost, whatever it may be. Okay, let's try another full example, but this time we're actually going to try to get our equation first before we get the visual, to find those key words that help us pull away the slope and the y-intercept. Jada earns $10 a week as an allowance for cleaning her room. For each additional household chore she completes, she earns $5. So, what are the two variables? Well, we are dealing with her allowance or her earnings and the number of chores she does, because the more chores she does, the more she gets in that week. So let's write our statements. Let E represent earnings. You could have said A for allowance. Let C represent number of chores. All right, what is the rate of change and what is the initial value? So I see two numbers here. The $10, that $10 isn't changing. It's $10 for the week. What can increase her allowance is the number of chores she does, because she gets $5 per chore. So that's already telling me, okay, $5 per chore means that $5 is the rate of change. And then the $10 is fixed. It's $10 for the entire week. Now, we know the slope, we know the y-intercept, let's put it together. We are talking about the total earnings. So E will be at the start. And then it's $5 per chore, so 5 times C. That way, if she does 2 chores, she's going to get 5 times 2, $10 additional dollars. If she does 5 chores, 5 times 5 is 24. She's going to get an additional $25 on top of the 10. So there's the slope, and then here's that initial amount, the $10 that she gets no matter what. Okay, we have our equation. It's still in y equals mx plus b, so nothing super fancier out there. Now that we have our equation and we know the scenario, let's fill in our table of values. So I know for 0 chores, she's still going to get $10. And now at this point, when you fill in the table, you can either use your equation or just use your knowledge of the scenario. So for 2 chores, she's going to get $5 for 1 chore, $10 for 2 chores. So on top of the $10 earnings, we can just add 10. And I can look at my equation and see if that works. 5 times 2 is 10, plus 10 is 20. Cool. That gives me some reassurance in my equation. If she does 4 chores, well, 4 times 5 is 20, so she gets 20 additional dollars on top of the 10 to go to 30. And now, once you see your pattern, you can just fill it in. Now let's go ahead and graph our line. So we're going to start $10 for 0 chores. There's that y-intercept. And then it's increasing by 10 for every 2 chores. Connect the dots. And my arrow on the right, not on the left, because she's never going to do a negative number of chores. Okay, some changes. How would the equation and graph change if she earns $4 for each additional chore instead of the 5? So why don't you pause the video here, write down how the equation would change, and then write down how the graph would change. Would the slope change, the y-intercept? What would it look like? All right, so your equation is going to be E equals Instead of 5c, we're going to have 4c, but that $10 isn't changing. Now it's the slope that changed, which means is it more steep or more shallow? The slope dropped, so the line will be more shallow. Look at what you wrote. Did you have enough detail? Did you say more shallow? Did you talk about the slope? How would the equation and graph change if she earns $15 for cleaning her room? So that's $15 instead of the 10 base fee. So again, pause the video, write down how the equation and graph will change. So your new equation should be E equals 5c plus, instead of 10, we have 15. So that's the y-intercept that's changing, which means the line will start higher because originally she was only getting 10. Okay, so there it is. Now let's finish up with 2 more examples. We're not going to do the full process with the graph, the table, all of that. We're just going to write an equation for each scenario. Because if you can do that, you should be able to do the rest of it. Maggie makes scarves. She charges $8 for one scarf plus $10 per hour she works on it. I see 2 numbers. I have to figure out which one's the slope, which one's the y-intercept. So we have the $8 and we have the $10. The $8 is for one scarf, and then she gets $10 per hour. The fact that I see this per hour, that's telling me that 10 is the slope, which means 8 should be the initial value. So she gets $8 no matter what for the scarf. If she puts in an hour of work, she'll get an additional 10. She puts in 2 hours, there's an additional 20. So our variables, the total cost of the scarf and the number of hours. One of your variables, you can always see it based on what that per is. It says per hour, so there's a variable. And then we are talking about cost, so that one will be the other. Let C represent total cost. Let H represent number of hours. So the total cost is equal to, thinking of y equals mx plus b, we know 10 is the slope, so it's attached to the variable, and the 8 just chills at the end. But you could have also thought of it logically. She gets $8 no matter what. If she worked for 3 hours, 3 times 10 is 30, so you do 30 plus 8. If she works h hours, 10 times h to get the total, and then add on the 8, which is exactly what this equation is telling us to do. Okay, last example. A small pizza costs $8 plus $0.75 per topping. Here are our 2 numbers, the 9 and the 0.75. You see per, that's our clue that 0.75 is the slope and 9 is the initial. So why don't you pause the video here? Write down your let statements. You should be able to tell what your variables are, and then write down your equation, then come back to check your work. So let C represent total cost because we are talking about the price here. And the total cost depends on the number of toppings. So let T represent number of toppings. So it's 0.75 per topping. So we would be multiplying 0.75 times T. And then you'll add on that base fee at the end. If you got that, great. If you didn't have it in y equals mx plus b, that's a problem because all of our lines will be in y equals mx plus b. And if you mixed up the slope and the y-intercept, be careful, take a note of that. Don't do that in the future. And that's it. So again, the y-intercept is going to be that initial value, initial price, initial height, whatever it might be. The slope is the rate. Look out for that per word to help you out. After that, you just put it in y equals mx plus b. Maybe there's a table of values, maybe there's a graph, and some changed little scenarios.